Now I want to discuss one misconception, and that misconception is partially functional complete. Okay, this concept, partially functionally complete. What is this partially functionally complete? This is a misconception many students have. Okay, a lot of students, I can say majority of the students, they have this misconception. So what is this misconception? Let me tell you. We will discuss this misconception of partially functionally complete. Also, we will discuss Boolean function versus digital circuit. Okay, what is this? Boolean function versus digital circuit means function versus circuit. This is also what we will discuss in this session. So let's start with this misconception. First, I want to discuss this misconception, that is partially functionally complete. Why I am calling it misconception? What do you think? I am calling this misconception, this partially functionally complete, I am calling it misconception. Why this is a misconception? Because this is not even a word. This is not even a standard concept. In any standard resource, you will never find this concept. Is this clear? This partially functionally complete, this is not even a standard concept. This is not even a word in the standard books, in the standard resources. See, there is no standard resource. There is no standard resource containing such concept. Is this clear? This is not a standard concept. This is self-made concept by some coaching teachers. Okay? You will never find any standard resource, any standard book, any standard lectures, any university, NPTEL, MIT, Berkeley, Morris Mano, Charles Roth. You will never find any standard book, any standard resource containing this concept. So don't use this partially functionally complete. Stop using it. Okay, and don't follow those, I can say, those people who don't follow standard resources. You should not follow those people. This is my honest suggestion to you. Follow those, either you follow standard resources. You can directly study from Morris Mano. You can directly study from Charles Roth. You can study from NPTEL. You can study from MIT. So either you directly follow standard resources, or you follow those who follow standard resources like Go classes. Okay, in Go classes, we always follow standard resources. And how do we give you proof that we are following standard resources? In Go classes, whatever you are learning, how can you be sure that you are learning from standard resources? Because we give you a screenshot. Yes or no? We always give you a screenshot of every concept that we teach you. Okay, so remember, in Go classes, whatever concept we teach you, we always give you some standard university or some standard book. A screenshot we will give you. Okay, that we are teaching you the concepts from standard resources. Now let's move on. Now let's see this. An important note. This is very important. Okay, and this is related to the partial functionally complete. You know, this misconception. I told you this is a misconception. This partially functionally complete, this is a misconception. This is not a standard concept. Okay, you will not find this in standard resources. But now there is a standard concept that is somehow, I can say, related to this. Okay, so let me teach you that. This is a concept. This is from standard resources. I will also give you the screenshot of standard book. So what is this? This is Boolean function versus digital circuit. This is what I want to tell you. Function versus circuit. Function versus circuit. Okay, tell me, what are functions versus circuit? Tell me. Do you understand the difference between Boolean function versus Boolean circuit? Tell me. Versus digital circuit? Let me know. Do you understand this difference? What is the difference between these two? Let me know. Please tell me. Do you understand? See, for example, what is a Boolean function? Boolean function, that is, for example, A or B. So this OR, this is a Boolean function. In digital circuit, this OR gate is a Boolean function, right? See, in digital circuit, this OR gate is a digital circuit, right? Yes or no? This is a digital circuit. This is a digital circuit. So remember, this A or B, this is a Boolean function, and this symbol, this represents OR gate. This is a digital circuit. Is this clear? Please tell me. So remember, gates are digital circuit. For example, gates. Okay, all your gates, these are digital circuit. Or for example, A or B, A and B, okay, your exclusive or A XOR B, A XNOR B, okay, A bar, all these are Boolean functions. A implies B, okay, yes or no? This A itself, these are Boolean functions. Is this clear? A NAND B, A NOR B. These are Boolean functions. And what are digital circuits? Gates are digital circuits. For example, a NAND gate. This NAND gate is a digital circuit. Okay, for example, multiplexer is a digital circuit. Yes or no? Multiplexer is a digital circuit. Is this clear? Decoder is a digital circuit. Please tell me. Encoder is a digital circuit. Did you understand the difference between function and circuit? And why I'm telling you this? You already know this. You already know that these are functions and these are circuits. Like gate is a circuit, mux is a circuit, this decoder, encoder, these things are circuit. NAND gate, this is a circuit. You already know this. Then why I'm telling you this? What is the reason I'm telling you this? The reason is this. For Boolean functions, when you have Boolean functions, then you cannot take advantage of 0, 1. But when you study digital circuits, then remember, by default, 0, 1 signals are available to us. By default, 0, 1, these signals are available to us. Is this clear? By default, these signals 0, 1 are available to us. Okay, so please understand that by default, these signals 0, 1, these signals, by default, these signals are available to us. But in Boolean functions, by default, these signals are not available. Is this clear? By default, you cannot use 0, 1. By default, you cannot use 0, 1. Is this clear? Unless it is given. Unless it is given to us. Unless it is given to us. Is this clear? Please tell me. Did you understand what I'm saying? See, I'm saying in the digital circuits, these signals are by default available to us. But in the Boolean functions, these signals are not available to us. Okay, let me give you an example so that you can understand what I'm saying. For example, Boolean function. On one side, I'm giving you Boolean function. On one side, I'm giving you digital circuit. Digital circuit. Okay, on one side, I'm giving you Boolean function. For example, this Boolean function, this implication function I'm giving you. Okay, let me give you implication function. Is this clear? Let me give you this implication function. F A comma B, that is A implies B. That is same as A implies B. That is same as A bar or B. That you already know. So I'm giving you implication function. On one side, I'm giving you this implication gate. On one side, I'm giving you implication gate. Okay, gate is a digital circuit, right? Okay, so I'm giving you this implication gate. So your implication gate, how will you create this implication gate? How will you create this implication gate? See, your implication gate will be something like this. Agree? Do you agree? Finally, you can see your F is equal to what? That is A bar or B. Please tell me, did you understand? This is your implication gate, right? Yes or no? This is your implication gate. Understood? Your implication gate, that will look something like this because that is your A bar or B. So this is your implication gate. Now you tell me, which of them is functionally complete? This is an interesting question I'm asking. Which of them is functionally complete? Which of them is functionally complete? Which of them is functionally complete? Functionally complete. Which of them is functionally complete? See, you might be thinking, sir, both are same. You might be thinking, yes or no? See, you might be thinking, sir, both are same. This and this, they are same. But what is the difference? See, you might be thinking, sir, this and this, they are same. They are same. This and this, they are same. But what is the difference? The difference is this is a circuit. So when you discuss circuits, then 0, 1 signals are available to us. Okay. So which of them is functionally complete? Let me tell you. Here you can notice in your set, what is your set X? In your set, you have only this. But here what you have? Here you have this also. Here you have this also. You have 0 also. You have 1 also. This is the difference. This is the difference. So when you study digital circuits, when you are discussing digital circuits, okay, so in the discussion of digital circuits, 0, 1, these signals are by default available to us. But here, these are not by default available. Now you check. Now you can easily notice this is not functionally complete. Now you can check this is not functionally complete. Okay, this is not functionally complete, but this is functionally complete. Is this clear? Please tell me. So remember, this is functionally complete. If I give you A implies B 0, 1, this is functionally complete. Okay, you can create everything here. For example, how to create not? For example, how to create not? Let me know. How to create not? I want to create not. How will you create not? Let me know. How to create not? Tell me. You can put B equal to 0. You can put B equal to 0. You can take help of this 0 signal. You can take help of 0 signal. So you got not. Now tell me how to create or. How to create or. You already have not. You already have not. You already have not. You already have not. This not you already have. Okay, this you already have. So finally I can say you got A or. Okay, yes or no? So this is functionally complete because you can create not also you can create or also you can create. Is this clear? So remember, this is functionally complete. This implication gate is functionally complete. Implication gate is functionally complete. Implication gate, that is functionally complete. Because whenever you are discussing circuits, whenever you are discussing digital circuits, then 0, 1, these signals are by default available to us. Okay. And what about this alone? If I ask you implication function, what about this implication function? Like, for example, if I give you only implication function, now this is not functionally complete. Why? This is not functionally complete. What is the reason? This is not functionally complete. What is the reason? You can easily see this is one preserving. You can easily see this is one preserving. This is one preserving. So because this is one preserving, so this is not functionally complete. Yes or no? This is one preserving, so this is not functionally complete. So please tell me, did you understand the difference between Boolean function and Boolean digital circuits? Did you understand the difference between Boolean functions versus digital circuits? Versus digital circuits. Let me know. Yes or no? So remember, in the Boolean functions, when you have Boolean functions, then you don't have, by default, you don't have 0, 1. By default, we can't use 0, 1. We can't use this 0, 1. Okay, by default, you can't use 0, 1 unless these are given, unless already given. Unless already given. Okay, unless already given. But in the digital circuit, by default, these signals are available. Okay, by default, remember these 0, 1 signals are by default available. Signals are available. By default, these signals are available. Okay, but see, you must ask me one question right now. Sir, what is the standard source of this? Yes or no? Are you thinking? Is there anyone here who is thinking, sir, you are telling that for Boolean functions, we don't have this, I can say 0, 1, we don't have by default, we don't have 0, 1. But how can you say that for digital circuits, by default, we have 0, 1? For digital circuits, how can you say that by default, these signals are available? Is there any standard source who is saying that these signals are by default available? And the answer is yes. Okay, so let me give you the standard source. That is your Charles Roth, this book. In this book, it is already given to you. In this book, it is given. Also, all the GATE exam question, all GATE computer science or GATE electronics, all the questions, they follow this. They follow this convention. So remember this convention. Okay, where it is given? Tell me where it is given. What is the source of this information? What is the source of this information? The source of this information is Charles Roth book. Okay, I will show you. Don't worry. The source of this information is Charles Roth book. Okay, and all the GATE exam and EC exam questions, all the GATE PYQs. Okay, but the main important source is Charles Roth book. This is the source. This is the main important source. In this Charles Roth book, it is already given to you. You can see here. Okay, see, notice here. It is given like this. Okay, we will always assume that 0, 1 are available as GATE inputs. Is this clear? Read this. Okay, forget about the other things. You can forget about the other things. Okay, just forget about the remaining. Just read this line. This line you read. We will always assume. What they are saying, tell me. Read this line. We will always assume. We will always assume that 0, 1 are available as gate inputs. Is this clear? Please tell me. As gate inputs, we will always assume that they are available. Please tell me, did you understand? Let me know. So remember, this is the source. Okay, you can check it out. Charles Roth book, Digital Logic Design. And so that is the reason I'm saying. So please understand that when you have Boolean functions, if a set of Boolean function is given to you, you cannot use 0, 1 by default unless it is already given. But in the digital circuits, like your gate, multiplexer, decoder, encoder, okay, all these things, in the digital circuits, by default, these signals you can use. These signals you can by default use. Is this clear? Please tell me. Let me know. Okay. Now you can check it out. The same thing you can check it out in all the gate questions. In all the gate questions, this thing you can check it out. For example, this is gate computer science question. Here you can notice this implication gate is given to you. Remember this implication, you can see this implication gate is given to you. This digital circuit is given to you. This digital circuit is given to you. And the question is saying that prove that this is functionally complete. Prove that implication gate is functionally complete. Is this clear? Remember, implication function is not functionally complete. Please understand. Please understand this implication function. If I ask you this implication function is not functionally complete. Okay, implication function, that is not functionally complete. Is this clear? Implication function, for example, this function A implies B, this is not functionally complete. Okay, if you have this A implies B, this is not functionally complete. But implication gate is functionally complete. What is the reason? Tell me. What is the reason? Because when you are discussing digital circuits, then 0, 1 signals are available to us. Is this clear? Please tell me. 0, 1 signals are available to us. You can see this is functionally complete. Okay. So you can see this was your gate computer science 1998 question. Let me tell you another. See this. Look at this. Here you can notice, just compare this gate exam question and this ISI exam question. You can see implication gate is given to you and the question is asking implication gate is functionally complete. Yes or no? Agree? Notice. This implication gate is given to you. The question is asking implication gate is functionally complete. Because digital circuit is given to you, so 0, 1 are by default available to us. Yes or no? By default, 0, 1 are available to us. But in this ISI question, functions are given to you. That is the reason you can notice this one they have explicitly given. Is this clear? This one they have given. They have given this one. But when you have digital circuits, then 0, 1 are by default available. Is this available? Is this clear? Please tell me. This 0, 1 are by default available. Please tell me. Now let's see the next. Question. For example, this question. This is gate electronics question. Again, you can see this implication gate is given to you. And the question is asking which of the following is true. Remember, because you are discussing gates, okay, gate 1, gate 2, digital circuits are given to you. The question is saying digital circuits are given to you. Now, which of these is universal? So remember one thing, 0, 1 are available to you. But this with 0, 1, this is also not functionally complete. Please understand. See, this OR gate is given to you. This OR gate, if you give 0, 1, then also it is not functionally complete. Okay, it is not functionally complete. Similarly, this AND gate with 0, 1, that is also not functionally complete. Okay, but remember this implication with 0, 1, this is a functionally complete. This is your gate electronics question. The question is asking which is true, and you can see gate 3 is universal gate. That can happen when gate 3 is universal gate, because we are discussing gates, 0, 1 signals are by default available. Is this clear? Please tell me. 0, 1 signals are by default available. As given in the Charles Roth book. This is already given in the standard resources. By default available. This is already given in the standard resources. Is this clear? Please tell me. Let me know. So 0, 1, these signals are by default available when you have digital circuits. This is your GATE computer science 1999 question. Okay. This is your 1999 question. Tell me, this is related to digital circuits or this is related to Boolean functions? See this question and tell me, this is related to digital circuits or this is related to Boolean functions? This is related to circuits. Okay, you can see multiplexer, gate, multiplexer. Okay, 3 input gate. Is this clear? This is related to digital circuits. So if you solve this question, then what you will assume? If you solve this question, this GATE exam question, if you solve, what you will assume? What you will assume? 0, 1 you can assume. Okay, 0, 1. Now you solve this question. Now you solve this question. Is this clear? Take 0, 1. Take 0, 1. 0, 1 are available to you. Now you solve this question. You will see answer is B, C. Can I give you as a homework? Can I give you as a homework? Now you can solve this question. In each option, you assume 0, 1 is available to you. In each option, in each of them, 0, 1 is available to you. Now you solve this question. I'm giving you this question as a homework. Okay, don't worry. I will provide you the video solution. Video solution I will provide you. Don't worry about it. Okay, don't worry about it. Okay, so this homework, take this as a homework. Apply post theorem. Apply post functional completeness theorem. Is this clear? So remember, whenever you have digital circuits, then 0, 1 signals, these are available to us. So this 2 by 1 multiplexer, this is functionally complete. Okay, this 2 by 1 multiplexer, this is functionally complete. Why? Because 0, 1 signals, these are by default available to us. Okay, so you can see. Is this clear? Please tell me. So this line is true. 2 by 1 multiplexer is functionally complete. This line is true. What is the reason? Because remember, these signals, 0, 1 signals you can use. Okay, are by default available. Are by default available. Are by default available. You can use them in the inputs. Okay, in the inputs. You can use them in the inputs. Is this clear? Please tell me. And this is another question you can see. This is another GATE exam question. The question is asking that you have half adder. Please tell me, half adder, is this digital circuit or what? Is this digital circuit or Boolean function? This half adder, this is digital circuit, right? Yes or no? The question is saying, prove that this is functionally complete. So tell me, do you have 0, 1? By default, do you have 0, 1? The question is saying, prove that this is functionally complete. Prove that half adder is functionally complete. So because this is a digital circuit, so 0, 1 available? Yes or no? 0, 1 are by default available. By default available. Okay, and you can see this type of comments happen because of misconception. Okay, you can see this type of comments, and you can see how many upwards are there. How many upwards? 10 upwards. This is a very common misconception. This is a major misconception. This is not even a word. Next time when someone tells you partial functionally complete, what you will do? What you will do? Next time when you see this word, partially functionally complete, what you will say? You will say, that's not even a word. This meme you can send. This is not even a standard concept. Okay, if next time, if some teacher, if some coaching teacher or some student, if they use this word, partially functionally complete, then you just tell them, give one standard resource which contains this concept. Give one standard resource which includes this concept. There is no standard resource. Is this clear? So this is just a major misconception. Anyway, the point is very simple. For the digital circuits, these signals, 0, 1 signals you can use for the digital circuits. Is this clear? Please tell me. Please let me know. Is this clear? So remember, these signals are available to us. We will assume that 0, 1 are available as gate inputs. This line is given to you in this book, in this digital logic design book. This line is given to you that we will always assume, please notice, we will always assume that 0, 1 signals, these are available as gate inputs. Okay, so this is your chapter. I hope all your misconceptions are over. Please tell me, did you have this misconception partially functionally complete? Did you have this misconception? So I hope now all your misconceptions are clear. Now you can solve all the GATE exam questions. Okay, every question you can solve. Every GATE PYQ, GATE computer science, GATE electronics, GATE instrumentation, okay, GATE electrical, any exam PYQs you can solve. Okay, and I promise you, if you understood this, if you understood post functional completeness theorem, that theorem you understood, okay, and if you understood all the examples, all the questions that we have taken, and if you understood that this misconception of partially functionally complete, that is a misconception. Okay, so all the things that I told you that we have seen, if you understood, then you can solve any question based on functional completeness. Okay, any functional completeness question you can solve without any confusion. Without any confusion, you can solve the question, okay, very easily. Please tell me, did you understand? Please tell me. Let me know. Did you understand? Please tell me. Are you confident in functional completeness? If I give you any set of Boolean functions, then can you solve it? If I give you any set of Boolean functions, then can you solve the question? Okay, are you confident? Very good, very good, very good. And one request I have, and this is a very major request. Okay, so I want to request you that on the Go Classes YouTube channel, I will upload these lectures, these functional completeness lectures I will upload. Okay, so please like and share. Please like, comment, and share. Please do that, because as I told you, all the resources, you know, all the YouTube videos who are teaching you wrong concepts, they are getting a lot of views. Okay, many on the YouTube, you can find many videos, you can find from Indian coaching teachers, you can find many videos in which they will teach you misconception. They will keep giving you misconception, but still those videos have, I can say, thousands of views, lakhs of views, okay, millions of views. So a lot of students, they are learning wrong concepts. Okay, a lot of students are learning self-made concepts by these coaching teachers. Okay, so I want to request you that on the Go Classes YouTube channel, whenever you find any video, then please like, comment, and share. Okay, so that at least students can understand, or students can learn the correct concept. Okay, so please do that. Okay, all these videos, this functional completeness, all these lectures, I will upload on the Go Classes YouTube channel. Please like, comment, and share. Okay, all these three are actually important from the YouTube algorithm point of view. All these things are important. Okay, like, comment, and share. Okay, so at least if you can do, at least do these two things. Okay, these two things, please do. Okay, so do these things, because as I told you, all these videos on the YouTube who are teaching you wrong concepts, they are getting thousands of views. Okay, and many students, they blindly follow them. Many students, what they do, they blindly follow one specific teacher. This happens with many students. Okay, as a student, you should not follow any particular teacher as a, I can say, blindly. Okay, don't follow blindly. Yes, you can follow, no problem. Okay, if you are following, no problem, but don't follow blindly. Okay, remember, finally, standard resources, that is the best material. Standard resources, if a concept is based on standard resources, if you can find that concept in the standard resources, then that is correct. Is this clear? So always follow standard resources, or you can follow those who follow standard resources. So you can follow Go Classes, because whatever we teach you, we always give you a screenshot from standard resources. Okay, so thank you everyone. So please like, comment, and share. Okay, thank you everyone. I hope you understood all these concepts. So this is your functional completeness. This is over. Functional completeness, this topic is over. I hope you understood. Please like, comment, and share on all the videos of functional completeness. Okay, thank you everyone. So Siddharth is asking, sir, one doubt. If some function is not functionally complete, it imply it is not a universal function. So Siddharth, the point is, when a single function or a single, I can say, a single digital circuit, when a single function or a single digital circuit, when it is functionally complete, single entity is functionally complete, then we call it universal. Okay, for example, NAND gate, the single NAND gate, that, you know, NAND gate itself, NAND gate does not need anyone else. NAND gate itself is functionally complete, so we call it universal gate. NOR gate, If you have NOR gate, let's assume you have many NOR gates you have. Using NOR gates only, you can create any function. You can realize any function. You can create any digital circuit. So NOR gate is universal gate. Is this clear? So remember, when a single entity, when a single function or a single digital circuit, when a single entity is functionally complete, then we call it universal. Is this clear? Okay. Any other doubt? Implication gate is universal gate. Yes, Satyam, implication gate is universal gate because implication gate is functionally complete. Remember, implication gate, you are talking about implication gate, that is a digital circuit. Okay. And with the digital circuits, whenever you are discussing digital circuits, with the digital circuits 0, 1, these signals are by default available. Okay. So implication gate is universal gate. Okay. Implication gate, NAND gate, NOR gate, these are universal gate. Satyam, is your doubt clear? Okay, thank you everyone. Okay, thank you so much.